Good morning to all. Myself, Dr. S R Shukla. I am a scientist here working in Institute of Wood Science and Technology, and along with me, there are two presenters, Mr. Bhushan and Mr. Priyank. We'll be talking about the structural wood composite, the work done at in IWST. This is a very good opportunity for us to showcase our research work, and there is a very good discussion has been going on the wood certification and the wood which is coming from the agroforestry sources, and how to make use of this wood for panel product industry. And structural wood composites are a part of this kind of wood composites. So I will be going some basics of the wood composites, and then we'll be talking about the particular LVL and Glulam, and then bamboo lumber and CLT, the cross laminated timber. So to give a brief introduction about the engineered wood, we can see some slides over here. The engineered woods is being produced. Either a log can be converted into different wood elements like veneer or chips or fibers or flakes, and these wood elements can be reassembled with some adhesive to make the composite material. So this will give us engineered wood composite. This kind of composites are also called the what is called the composite wood or reconstituted wood or manufactured wood, and it is also called man-made wood. The good thing with these wood composites is that they can be designed to a particular technical specification, so that they are best suited for different kind of end uses, and they can meet the various national as well as international standards very easily. And they are available for not only for residential construction and commercial buildings, but also for industrial products. Here in this slide, you can just see the log from the forest or from agroforestry sources can be converted into different wood elements like veneer or small lumbers or fibers, and then these elements can be reassembled into plywood. If it is a veneer, it can be assembled in form of plywood or LVL or glue parallel lamp, I-joist. These kind of products can be made. Then lumbers can be converted into glue lamp, and then if it is converted into particles or chips, then chipboard or particle board, and flakes can give us the OSB, oriental stand board kind of things. And then if it is still finer scale, fibers can produce the MDF and SDF kind of thing. Now this is a big class of composite. It is called engineered wood composite. This can be further classified into two different groups. One is the structural group and another is the non-structural group. Under the structural group, which is a load-bearing component, where we can apply the load and they can be used for different load-bearing applications like LVL, Glulam, CLT, parallel stand lumber. These are the composites which comes under the structural class, and non-structural class like plywood, particle board, MDF kind of thing. So now, in general, what are the properties of these wood composites? As it is discussed that these can be produced from either wood scrap or wood base, or from the different wood veneers. They are layered composites, and then once we can select from the veneers can be graded, and we can select the better veneers, less of natural wood defects, and those can be reassembled. So engineered wood composites have some improved properties compared to corresponding solid wood. For example, they are more dimensionally stable. They improve, they exhibit improved properties like strength properties and other mechanical properties. They are stronger than the corresponding solid wood products of the same dimensions, and they provide greater efficiency of the natural resource by using a smaller and lower quality woods while permitting longer and strong spans. The size of these lumbers can be even much bigger than the corresponding solid wood products. Now, what are the advantages and applications? They are very versatile products. They are available in different sizes and grades, and different they can be classified in different durability class depending upon the kind of chemical treatment we are providing them, and they can be used for different construction applications. They are very easy to handle with the basic tools, drills, routing, jointing, gluing, fastening is very easy with these kind of products. Designing is very important, and they can be designed to any kind of product because they are generally available in larger size and bigger spans. Regular sizes are available, and even for they are being used for structural applications like joint, columns, beams, and they can replace many conventional building materials like steel and plastic and concrete. We'll be happy to know that our institute is coming up with a wood building, and we are planning to use this kind of engineered wood products in our this wood building. This is a technology demonstration center will be there, and we'll be demonstrating these kind of technologies in that center also. Now we will talk about the engineered wood market around the globe. And this kind of market can be generally subdivided into different types. Like on the basis of the type, this market is divided into like plywood, LVL, I-beam, glulam, OSB, CLT. So this is one kind of market which is available. Then depending on the application, what kind of application these products can be made into, like construction, furniture, flooring, packaging. And then by market can be divided in terms of end users, like whether it is for residential or for commercial or for industrial applications, and by region wise. So different types of markets can be analyzed. As far as the production and consumption of these kind of engineered wood products is concerned, there is a huge opportunity, and there is a huge market for these kind of products. You can see the world engineered wood market is valued at around $284 billion in 2019, and it is expected to reach to $400 billion by 2027, registering a CAGR of 6.2%. Even latest technologies can be adopted to bridge the gap between the production and demand for these wood-based products in India. In India, we can see these two graphs, which I have taken from the Bansal sir, this paper, where this plywood and blockboard is around 8.9 million cubic meter production, and particle board and OSB is around 1.1. And MDF and SDF is around 1 million cubic meter. And as we know that a lot of wood is being imported, and along with the solid wood, we are also importing plywood and particle board and MDF from different countries. So this is the right hand side. This import figures are given. And now, what kind of adhesives are generally being used for producing this kind of engineered wood composites? As we know, urea formaldehyde, phenol formaldehyde, melamine formaldehyde, and MDI, polyurethane, they are being basic in the commercial resins which are being used for producing this kind of engineered wood composites. And these are different types of preservative methods and wood preservatives which we can use with this, like pre or post dip method, brush or coating and spraying, glue line treatment, and vacuum pressure treatment. These are the different types of treatment and different chemicals depending upon the whether it is for interior application or for exterior application. So along with these advantages, we have a few disadvantages, like engineered wood product may burn quickly because of the presence of the wood in that, and they require some energy to process and manufacture. Adhesives are being used, which may be toxic, and formaldehyde release, if adhesive is like urea formaldehyde or phenol formaldehyde or melamine formaldehyde, then release of formaldehyde can be there. So we have to control that, and they can be sensitive to humidity and changes in the moisture level in the environment, and they can take the absorb the water also. So now I'll talk about the laminated veneer lumber, which the work our institute has done in the past, and the glue laminated timber. Laminated veneer lumber is a very versatile wood product, which is a load-bearing structural composite. It can be used for different building and construction and other load-bearing applications. They are produced generally in thicker sizes. Here, instead, unlike the plywood, where adjacent veneers are cross-oriented, here in LVL, all the grains of the veneers are oriented in the same direction. This is the basic difference between the plywood and LVL. And LVL can be of thicker size, like 2 inch or more, depending upon the requirement. And it has been told that it is manufactured from, because it is manufactured from the veneers, LVL makes up to 35% more effective usage of log than it's possible with the solid lumber. We have to convert a log into veneers, and then those veneers can be graded. They can be dried, and this is the manufacturing process where veneers are graded. Good quality veneers can be assembled together, and better quality product can be produced from that. And then these graded veneers are generally glue is spread over them, and they are assembled and pressed under temperature and pressure in a hot press, and then this kind of products are available for different usage. These are the different properties, important properties of LVL. They are available in big sizes depending upon the press capacity. If we have continuous press, we can make longer LVL, and they have very uniform properties. Like, because we can choose the veneer, the poor quality veneers can be segregated, and all good quality veneers can be used. So properties can be uniform. There won't be much variation in the properties like strength or stiffness or other properties of the LVL. They show the greater dimensional stability. They are higher in strength, available in the required shape, and maybe comparatively lower price if they are produced in larger scale. And there is an Indian standard for this, IS 1461699, which is available and related with the laminated veneer lumber. So this can be referred while producing the LVL for different applications. Now this is just a comparison of the properties of LVL and LSL, laminated splint lumber, and solid rubber wood and teak wood. Here we can see the LVL produced from rubber wood is having more or less comparable properties with the solid teak wood, and much better than solid rubber wood. So rubber wood LVL, some work was done in this institute with the rubber wood veneers, and also we have used the mango veneers and neem veneers, and some other wood species also being used for production of the LVL, and we have found that those LVLs have much better improved properties compared to corresponding solid wood, and their properties may be better or comparable with the teak wood. And what are the uses of LVL? They can be used for I-beams and I-joist. They can be used for load-bearing applications like for trusses, doors and windows. Frames can be made out of this. They are being used for furniture, truck bedding and floor beams, and even for custom-made panels for marine uses. So there are plenty of applications of laminated veneer lumber, and along with the OSB or plywood, they can be used for as a I-beam, so or I-joist. So here you can see the picture of I-joist where it is used for pre-flooring applications and even for roofing applications, where LVL is used as a flame and OSB used as a flame for making the I-joist. This is the picture of I-joist where it is being LVL is being used along with the plywood or with the help of OSB, and there are plenty of applications of these LVL. They are being in India. We have few companies which are producing the LVL at a very small scale, but there is a requirement of this kind of product and a larger scale. Then we have to go for larger scale productions. These are few pictures where LVL has been used not only for construction application, even for it is being used for different furniture applications. So this is a very good product which can replace the conventional wood in a big scale. And then another product which I am going to give some introduction about, the Glulam. It is also a very versatile wood product where a bigger slabs of 2 inch by 4 inch are generally glued together side by side or on the broader side to make the Glulam. So Glulam is also a kind of a structural composite which is being used for different applications. In our institute building, we will be using this Glulam also for making the different elements in the building. And here the grains of these laminations run parallel like LVL along the length of the members. Glulam's members can be manufactured from a variety of smaller trees harvested from the plantations, just like LVL. Here we need not to make the veneer out of logs, but small slabs can be used for making the Glulam. The Glulam provides the strength and versatility of the large wood members without relying on the solid wood timbers. You can see this picture. We have the solid wood here, and the strength of the solid wood is in the range of 24 megapascal. But when we convert it into Glulam, it will be around 27 megapascal, and then if it is converted into LVL, the strength will be around 48 megapascal. So depending upon the process and the product, the properties of these elements can be improved because of the less amount of defects present in there, and because of the presence of adhesives in between the layers. This is the manufacturing process of Glulam, where we are taking the timbers, then we have to dry it. The strength grading is required, and after that, if we want longer length, then finger painting can be used, and then the adhesives can be applied, and then side by side they can be pressed on the broader side, and then these kind of Glulam products can be produced. So very easy process, just like that. And they have a lot of applications, Glulam, in the building. Particularly, you can see here these products which are vertical columns and horizontal beams can be produced from Glulam. Even they can be curved into different shapes. And then straight beams, ridge beams, floor beams, trusses, tied rafters, tied arches, and hard bridge supports, curved beams. There are different load bearing applications of the Glulam. And these are building applications of the Glulam. Even they are being used for making the bridges. So this is all about the work on the LVL and Glulam, which was done in our institute. And now I will invite Mr. Bhushan to tell about the laminated bamboo lumber, and followed by Mr. Priyank, who will be sharing the CLT, the cross laminated timber. Thank you very much.